we've got some file-based ones that you'll be able to do yourself no matter what platform you're on. And so the first thing we're going to do here is ingestion, embedding, and vector searching. And what I'm going to start by saying here is that if we wanted to, we could actually do this with this much code. So this would do essentially the same thing. In fact, this is doing it with parse PDF 10K data from an object store. And this is all it takes to do everything that we're about to do. But instead of using Kamiwaza's ingestion service, which is the higher level abstraction, we're going to go one level down and drill into the things that happen under the hood. And we're going to start by checking out the transformer stocks. So here we go. It's 1,405 files is what we just saw, and it's actually turning up a bunch of workers to do this. Now, there's a few files in the documents that don't process very well from the perspective of generating embeddings and doing auto offsets. Like, we generate them, but they have unknown tokens because they've got weird things like the hugging face smiley emote a bunch of times, or huge blocks of base64 encoded text. In those cases, we get some warnings because we give up on doing auto offset tracking, but it's a tiny minority of the files, handful versus thousands, right? And we look at the results here, we'll see these are all the batches. So we see some batches were capped at 128 because that's where they kind of roll over into the next worker. Some, we finished processing an entire chunk of source documents, and then it was only a small batch to be inserted. No big deal either way. Now we have searchable vectors, though. Like, that did all the work for us. And if we did this on 100 terabytes of data, it could be massively in parallel. And the great thing about Ray is that it's going to do some work for us under the hood here of continuously reading some files in order to fill the batch that's doing embeddings, which will then fill the batch that is doing the vector database inserts. But if we were doing this on 10,000 files that were very large, it's not going to read all 10,000 files and then do the work. It's going to read enough files to fill the batch. And so that batching mechanism is built in and then thus built into Kamiwaza. And so now we can actually search, and we're just running some code here to search. So you can see our query here is essentially what are the parameters for auto model from pre-trained. Quick tour, good place to start, right? Who wrote the paper that presented the MBART model? Turns out MBART is going to be the first result, shockingly, right? In this case here, we actually took an exact quote out of the UMT5MD page, and you can see it is the first result, although I always like to point out it's super, super close to the next result. So dense embeddings are mysterious. In the future, using a Kamiwaza hybrid retriever can be useful for things like this because we can merge dense embeddings, sparse embeddings, and like classic reverse indexes, bag of word searches. I have a search here. What movie? It's Demolition Man, by the way. Paired Sandra Bullock and Wesley Snipes early in her career. And you can see that these relevancy scores, these distance scores from the vector database are much lower than the other distance scores because these are irrelevant. And actually, with this particular vector database and its index type, we couldn't, if we had two completely dissimilar documents, I think we'd have a score of 0.6. So that's completely dissimilar. And so these are actually pretty unrelated, which you'd expect, right? Because obviously none of the Hugging Face transformer stocks cover that. Now, what's interesting is because we have this data with the relevancy scores, we know the source document. This is not something the vector database does by default, right? Kamiwaza is inserting this metadata, and it's not making you create a lot of things around the schema. When we define the schema up here, and we actually defined, when we defined the schema, we actually listed these fields, even though we didn't put them in, you notice they're comments, because Kamiwaza was automatically defining model name, source, and offset. We did put catalog URN, and that other notebook that I showed you, this instant ingestion service, it will actually then create the catalog URN for you also. But because we're doing it step by step, we're going to do it ourselves here. But Kamiwaza does a lot of work to make this really usable in the future.